Students, now we will study our next topic, that is chemical properties of metals. Metals and non-metals show different chemical properties. First, we will describe the chemical properties of metals and then of non-metals. The important chemical properties of metals are as follows. First is reaction of metals with oxygen. When metals are burnt in air, they react with oxygen of air to form metal oxides. Thus, metal react with oxygen to form metal oxides. Metal oxides are basic in nature. Some of the metal oxides react with water to form alkalis. Metal oxides, being basic, turn red litmus solution blue. The vigor of reaction with oxygen depends on the chemical reactivity of metal. Some metal react with oxygen even at room temperature, some react on heating, whereas still others react only on strong heating. Here are some examples for it. Sodium metal reacts with oxygen of air at room temperature to form a basic oxide called sodium oxide. Potassium metal also react with the oxygen of air at room temperature to form basic oxide called potassium oxide. Most of the metal oxides are insoluble in water, but some of the metal oxides dissolve in water to form alkalis. Sodium oxide and potassium oxides are two metal oxides which are soluble in water. They dissolve in water to form alkalis. Sodium oxide and potassium oxide dissolve in water to form alkalis. For example, sodium oxide is a basic oxide which react with water to form alkali called sodium hydroxide. Due to the formation of sodium hydroxide alkali, a solution of sodium oxide in water turns red litmus to blue. Potassium oxide is also a basic oxide which reacts with water to form an alkali called potassium hydroxide. Due to the formation of potassium hydroxide alkali, a solution of potassium oxide in water turns red litmus to blue. Students, our second chemical reaction is reaction of metal with water. Metals react with water to form a metal hydroxide or metal oxide and hydrogen gas. All the metals, however, do not react with water. The intensity of reaction of metal with water depends on its chemical reactivity. Some metals react even with cold water, some react with hot water, some react only with steam, whereas others do not react even with steam. When a metal reacts with water, cold water or hot water, then the product formed are metal hydroxide and hydrogen gas. When a metal reacts with steam, then the product formed are metal oxide and hydrogen gas. We will now describe the reaction of metals with water or steam by taking some examples. Potassium and sodium metal react violently even with cold water. For example, potassium reacts violently with cold water to form potassium hydroxide and hydrogen gas. The reaction of potassium metal with water is highly exothermic due to the hydrogen gas formed during the reaction catches fire immediately. Thus, potassium is a very reactive metal. Magnesium metal does not react with cold water. Magnesium react with hot water to form magnesium hydroxide and hydrogen. In this reaction, the piece of magnesium metal starts floating in water due to the bubbles of hydrogen gas sticking to its surface. Calcium reacts with cold water, but magnesium reacts only with hot water. This shows that magnesium is less reactive than calcium. We will now give the reaction of magnesium metal with steam. Magnesium reacts very rapidly with steam to form magnesium oxide and hydrogen. Please note that when magnesium reacts with hot water, it forms magnesium hydroxide and hydrogen. But when the same magnesium reacts with steam, it forms magnesium oxide and hydrogen. Students, our third reaction is reaction of metals with dilute acid. Metals usually displaces hydrogen from dilute acid only. The less reactive metal like copper, silver and gold do not displace hydrogen from dilute acid. When a metal reacts with dilute acid, then a metal salt and hydrogen gas are formed. Metal plus dilute acid gives metal salt plus hydrogen. All the metals, however, do not react with dilute acids. The vigor of reaction of metal with dilute acid depends on its chemical reactivity. Some metals react explosively with dilute acid. Some metals react rapidly. Some metals react only on heating, whereas others do not react at all. We will describe this with the help of dilute react dilute hydrochloric acid. Metals react with dilute hydrochloric acid to give metal chlorides and hydrogen gas. The reaction of metals with dilute hydrochloric acid will be shown in the following reaction. So, for example, sodium metal reacts violently with dilute hydrochloric acid to form sodium chloride and hydrogen. This reaction shows that sodium metal is very reactive. Magnesium reacts quite rapidly with dilute hydrochloric acid, forming magnesium chloride and hydrogen gas. The reaction of magnesium with dilute hydrochloric acid is less vigorous than that of sodium, so magnesium is less reactive than sodium. Students, our fourth reaction is reaction of metals with salt solution. When when a more reactive metal is put in salt solution of less reactive metal, then the more reactive metal displaces the less reactive metal from its salt solution. In other words, a more reactive metal displaces a less reactive metal from its salt solution. The more reactive metal takes the place of less reactive metal and forms its own salt solution. For example, if metal A is more reactive than metal B, then metal A will displace metal B from its salt solution to form salt solution of metal A, and metal B will be set free. Let us take some example to make this point more clear. The reaction of zinc with copper sulfate solution. When a strip of zinc metal is put in copper sulfate solution, then blue color of copper sulfate solution fades gradually due to the formation of colorless zinc sulfate solution, and red-brown copper metal is deposited on the zinc strip. In this reaction, zinc metal is displacing copper metal from its salt solution, copper sulfate solution. This displacement reaction occurs because zinc is more reactive than copper. If, however, a strip of copper metal is placed in zinc sulfate solution, then no reaction occurs. This is because copper metal is less reactive than zinc metal and hence cannot displace zinc from zinc sulfate solution. If we put silver metal in copper sulfate solution, even then no reaction takes place. This is because silver metal is less reactive than copper metal and hence cannot displace copper from copper sulfate solution. Iron and magnesium metal are however more reactive than copper metal, so they can displace copper from copper sulfate solution. Fifth reaction, reaction of metal with chlorine. Metal reacts with chlorine to form ionic chlorides. In the formation of metal chlorides, the metal atoms lose electron and become positively charged ion, whereas chlorine atom gain electron and becomes negatively charged chloride ion. In other words, metals from ionic chloride because they can give electron to chlorine atom to form ions. Metal chlorides are usually solid and conduct electricity in solution or in molten state. Thus, metal chlorides are electrolytes. Metal chlorides have high melting points and boiling point. So, metal chloride are non-volatile. Let's take some example for the better understanding. Sodium is a metal, so sodium readily reacts with chlorine to form an ionic chloride called sodium chloride. Sodium chloride is ionic compound or electrovalent compound containing sodium ions and chloride ion. Sodium chloride solution conducts electricity. It is an electrolyte. Calcium is a metal which reacts vigorously with chlorine to form an ionic chloride called calcium chloride. Sixth reaction, reaction of metals with hydrogen. Metals generally do not react with hydrogen because metal form compounds by losing electron and hydrogen also form compounds by losing electron. So, normally a hydrogen atom does not accept the electron given by metal atom to form a compound, but a few very reactive metal can force the hydrogen atom to accept electron given by them and form salt-like solid compounds called metal halide. Thus, most of the metal do not combine with hydrogen. Only a few reactive metals like sodium, potassium, calcium and magnesium react with hydrogen to form metal halides. Metal halides are ionic compounds formed by transfer of electrons from metal atom to hydrogen atom. In a metal halide, the hydrogen is present in the form of negative ion called halide ion. Let's take some example for the better understanding. When hydrogen gas is passed over heated sodium, then sodium halide is formed. Sodium halide, that is NaH, is an ionic compound containing sodium ion Na plus and halide ion H minus. When hydrogen gas is passed over heated potassium, then potassium hydride KH is formed. When hydrogen gas is passed over heated calcium, then calcium hydride is formed. Calcium hydride is an ionic compound containing calcium ion Ca2 plus and hydride ion 2H negative. Similarly, when hydrogen gas is passed over heated magnesium, then magnesium hydride is formed. Its formula is MgH2. Magnesium halide is also an ionic halide. The comparatively less reactive metal than zinc, copper and iron do not react with hydrogen to form halide.